Yeah, hello everyone. So today we're gonna build this paint stroke effect here. So we built a paint stroke capsule inside Scene Nodes. First, I'd like to show you then the actual stroke shader. This I will just show you. We don't gonna build this. And in the second part, I'd like to explain you the actual concept, how this effect works. Then in the third part, we try to rebuild this effect in MoGraph. So if let's try how far we can go with MoGraph to build this effect. And then in the fourth part, we of course building the Scene Node setup. And in the fifth part, I'd like to show you then the final advanced capsule. So for you that you can use to build your own paint stroke effects. And I think that's it for the introduction. But before we jump in, I'd like to give some credits here to the Digital Life project here. It's from the University of Massachusetts, I think. So they built here this photogrammetry project, yes, from the University of Massachusetts. So there you can download those pretty cool animals. Some of them are also animated. Of course, you can download them for free for non-commercial purpose, of course. So we gonna build our setup here with this loggerhead sea turtle. Yeah, so let's jump into Cinema and start with our project. So as I said, I first like to show you the paint stroke shader. So of course here I built this all with noises, but you can also use a bitmap for this. And here of course you can be as creative as you want. So you can build your own paint stroke. So I just activate this here. Just here I have here a color map. So a diffuse channel here. So with initial color and with some noises here, two different noises. And then I have an opacity here. This is here our opacity map that is also just this noise here for the back. So we have this kind of canvas pattern here, and then those two ramps here. And the canvas pattern I masked here with also a ramp, and then we have something like this, and then also add some contrast, added a noise, and this is our final opacity. So, and then here I have a random offset. So when I change the color here, we get automatically here another stroke. So it picks all the RGB values, makes some math here, and then we have for every color that we input, then we have another stroke. So that's it here for the stroke shader. Let's go to the next part. So let me explain how the effect is working. So we can see here the final image here with our turtle, and we can see we have here again our paint strokes that are cloned onto the surface. So we have to clone them first, and then you can see it follows here the flow of our model. So this flow we can, let me deactivate here the paint stroke. Let's show the turtle. We can paint with lines. So we have here splines that we can paint onto the object, and with those lines we define the flow of our strokes. So we actually sample the tangent vectors. So when we go to point mode, here's already a point selected. Let's zoom in. Maybe let's solo it. So you can see every point here. So when we paint onto the surface here, we will do this with the where is it, with the sketch tool. And so every point now has two tangents, so those white two dots, and we need read those tangents, and those tangents then will give us a direction vector, and with this direction vector we will align here our strokes. So this is actually the next step. So you can see here, let's deactivate solo. So we have to sample tangent vector, and then we like to align here our stroke to the camera and to this tangent vector. So because this is the next part, when we jump out of the camera, because we build a 2D effect, all the strokes have to align to the camera. So because it's 2D, so you can see here's our camera, and you can see all the strokes are pointing to the camera. So we have an alignment to the camera and an alignment here along our our splines here, along those tangents here. And then the next part is then you have to sample the actual color. So we just show the turtle here, and maybe let's show the here the color. Here we have the diffuse color of our turtle. We have to sample this texture, and then we add this color to our paint strokes. And then finally we like to have lighting. So the lighting we build with let's activate this here, deactivate the color again, and you can see we have here a light source. It's just it could be a light. It could also be just a null object. So we can move this null object around. So then we can build our own lighting. So this will be the last step then. So this is it for the concept. So we have these 5 steps here that we're going to build. But first we try to build it with MoGraph. For everybody who is just interested into the scene node part, can skip the MoGraph part. So let's jump into the MoGraph part. Okay, here we have our sea turtle. So when we remember here, first we like to clone strokes. So we need a stroke first. Let's make a plane. Let's make it smaller. So maybe something like this, maybe a little bit smaller. Then we like to clone this onto the turtle. So go to the cloner, then go to object, then add here our turtle. And then of course we need a lot of strokes. So let's maybe add 1,000. So now we have here the strokes, and I think best way to think the up vector here, the orientation y plus is okay for now. And then what we need is the sample a tangent vector. So this is the one of the downsides here in when we build it just with MoGraph. So what we can use instead of a tangent vector, we can use just a noise. So, but let's first align our strokes here to the camera. So we have here already a camera, and we can do this with the target effector. Inside the target effector, add the camera here. I think you can just choose here, look to camera. And now I think we have to, because it aligns along the z-axis. Yes. So we have to switch it here to Z plus. So we have here all the strokes are looking to the camera. So, and then of course we like to build this tangent vector. So we, in this case here, we just use a random effector. And some noise. Don't want position. We want just rotation. And here instead of the banking, add some rotation here. Then I think let's make the noise a little bit smaller. Yeah, something like this. And now we have some kind of a flow over the surface. Maybe let's show the mesh. I don't need this much segments here. One, okay. Then next part is we like to sample the color. So here inside MoGraph, we can do this with a vertex map. So with a shader field, that's the easiest way. So first let's hide here the cloner, go to our turtle, add a vertex color. Vertex color. Inside the vertex color, use transfer. Remove the freeze and let's add a shader field. Then let's grab here our texture. Here the turtle. Here we go. I think this resolution is fine. So I have here the texture of the turtle transferred here to our vertex color. And this vertex color we can use inside of the cloner to color our paint strokes here. So let's use a plane effector. Maybe let's call this color. Then deactivate position. Then let's go to the fields. Then add here our vertex color. And you already can see we transferred here the color from our turtle onto our strokes. Then I think let's grab here our paint stroke. It's already in here. So add this to the cloner. So inside our paint stroke, so it's the same here. We have here, instead of just the color here, we have here the MoGraph color. So we'll find this here when you add a color user data. So color user data. It's this one here. Then you go to presets, then to MoGraph color, and then you have here the MoGraph color. Great. So let's hide the turtle and maybe let's check the render. Let's zoom in. Oops. And I think the alignment here of our stroke is the wrong alignment. So I think we have to make the width here to 2 and the height to 6. This looks better. And then of course we have to rotate it. So an easy way is just to place here our plane inside of an connect object. Then rotate the plane here. Oops, that's the wrong one. I think the banking, yes, it's at 90 degrees. Then let's zoom out. Then we need a lot more strokes. Maybe let's make them a bit bigger here. 3. Maybe also change the resolution here. Here we go. Then add way more strokes, maybe 10,000. Then switch it here to multi-instance so it is faster. So you can see we have here already our turtle here. And when you want to see the color here in the viewport, just type in NQ. So this is disabling here that activates here the textures, disabling it and activates it. So, and now we already have here a pretty nice effect, but also one of the downside here when we go here to our tasks here. So what is the last thing? You have to build the lighting. So there is no way to build the lighting also here inside MoGraph. So, but I prepared a small capsule for you. It will be also included inside the file you can download on Gumroad, where we can build a light vertex map. So let's go to the browser, type in light. It's this one here. It's the light vertex map. We add this to the turtle here. Maybe let me show. Let's close this one. This one. Deactivate the cloner. Let's have a look at the turtle. Here inside the light vertex map, we need a light object. So we will build this with a null. So add a null. Let's use maybe I think a pyramid is nice. It looks into the Z direction, as normally also lights will look into the Z direction. Let's move it up, rotate it, something like this. Or maybe, yes, like this. Then go to the light vertex map. Maybe call it light. Add our null here. Then you can see here on the turtle, you have two procedurally generated vertex maps. So the light map and the shadow map. So let's check. We can see we have here a light map. So when we rotate here our light, see we built here a light map. And then you have also a shadow map. So where we have shadows. So you can use directional light, or we can also say the light type here is a point light. So this is the shadow map. Maybe we just use the light map here, so you can round. Yeah, I think you get the idea. So, whoops, you will find this this capsule here. It is embedded in the file you can download, so you can of course use it also for other projects. But now the cool thing, we can use this vertex map here inside our color map. So let's add this also to here. Then we have to say, because at the moment you have just the color here from our texture. Then we go to the mapping here. The mode is index. Then go to remapping, enable remapping. Then we like to have the color remapping, and we like to have a gradient. And then as type, use overlay. So when we add here in the center, not with 50%. So this will not affect here our shader here. So now we can play around. Maybe let's use here a dark blue for the shadows. Maybe let's bring them up here. And then for the light, maybe a light blue, something like this. Maybe clip this a bit. Here we go. And now we have a light effect on the vertex map. So we can move the light. And this, of course, will also be transferred here onto our strokes. So let's check this inside of the render. Yes, here we go. And then, of course, for the last step, we can add some, because every stroke now has the same size. Let's add another random effect. Whoops, here, random effector. Add this to here. Maybe say random scale, and add some random scale. Random, that's fine. Deactivate position, add scale, uniform scale. So something like this. Maybe it's a bit too much. Then also hide the turtle. Yeah, here we go. I think that's it here for this example, just for rendering, because our texture, I think our diffuse is the color here of the emission color. So we inside the render, we don't need like global illumination and all this stuff. So when you go to Redshift here, of course, motion blur you can, or I think we don't need motion blur. We also don't need all those. We just need transparency. There we need a lot. So because the strokes are overlapping, we need a lot of traces here in the transparency. And also we don't need global illumination. And for the speed, you can use here the biggest bucket size. And then also the threshold can go up to 1. So you have a pretty fast render. Yeah. So that's it for the MoGraph part. And the next part will be, of course, our Scene Node part. So let's jump to the next part. Okay, here inside a new file. Here we have again our turtle back here. And before we jump into nodes, as I explained here, we like to sample our tangent vectors from our flow splines. So we have to paint the flow splines first. So let's use here the sketch tool, then activate snapping, open the snapping settings, deactivate points and activate polygons. And now let's start to paint onto the surface, maybe something like this. That's fine for now. Now we have here our tangent spline here. And you can see when we select a point here, let's hide the turtle, you can see every point has these 2 tangents, and those tangents we're going to read to build our tangent vector. Okay, fine. So then let's build a capsule. So a nodes capsule, because we like to, as same as we did in the MoGraph example, we like to scatter those strokes onto our surface. So there we can use an object group capsule. So let's search for group, and here is the object group capsule. With this one we can see a generator, we can generate instances. So same as on MoGraph, instance, render instance and multi-instance. Of course we're going to build multi-instances. You can see here this little yellow flask here, so that means this workflow here with instances is still in experimental mode, so stuff can change in the future. So, but for our purpose here, this works fine. Then let's open here our capsule. Bring this down here. So we have some space here. And first thing, as explained here, let's make this bigger. We like to clone strokes onto the surface, so we have to bring in our surface. For this, we can here right click to the add an input, and there is the object link. So this is our, call it surface object. Then because we also need the tangent later, we can already prepare this. So add another link here and call it tangent spline. Perfect. So always good practice is to transform first. First we have here our geometry, and if our geometry is somewhere in space, we have to also transform the geometry first with here our matrix. So this is always good practice here to do this first. So transform geometry by the global matrix here, and then the same here for our tangent spline here. So we import here the transformed geometry. Great. Then let's go here to our object group. Maybe call this paint strokes. And then here under inputs, let's import our turtle as surface object, and already here our spline here as tangent spline. So, and now we like to clone onto the surface. So first we need our stroke geometry. So as you did in the MoGraph example, we use a plane for this. Here we go, a plane. Because we're going to build an instance of our stroke here, of our plane, we just have the geometry. We can switch this to an operator. So right click, toggle node type, and now we have an actual operator. So on this one we can export here. You can see we have here our plane. Then make some adjustments. Maybe also make this way smaller here. Let's hide the turtle for now. Oops. Let's make it something like this. That's okay. Then we don't need a lot of segments. And we can already make some parameters here with the width and height. So I think we can use them outside of our capsule. Great. And now we like to clone this plane onto here our geometry. So we can use the distribution for this. So the best distribution is actually when you go here on the, where is it? Distributions. You have a lot of different distributions. And the best one in this case is actually the surface blue noise. So where is it? Surface blue noise. Let's use this one. Then add here our geometry to the surface blue noise. And then we can plug here the distribution straight to the matrix. Here we go. You can see inside the distribution have a lot of other information, but we just need the matrix here. So actually we just need the translation in this case because it aligns here to the surface. We don't need this. We do our own alignment. So let's just use the translation. Great. And then before we go here to the sampling of our tangents, we also like to add some random scale. So we can do this with a hash. Let's add a hash node. Then let's use the index here to the seed, and then the salt we can use as a scale seed. Great. Oops. And then we to use here the float here, and this float is between minimum and maximum here. So we can also define the minimum maximum scale maybe outside here. So minimum, min scale and max scale. So bring them in here, then put them up here. So everything is nice and organized here. And then here the value, float value, we can plug in directly into the scale. And you can see now we have different scalings here. Great. This is our random scaling. So perfect. So the next part, as explained here, we like to sample here the tangents, so the closest tangents for each point. So when you have the surface here, maybe let's make the turtle X-ray, and let's say for this point here, for this stroke, the closest is actually this here, this spline, so you can read this point, and we actually need not just one point, we need more than one point and build an average. So for maybe a point that is in between, so maybe let's say, to make it a little bit bigger, let's say this paint stroke here is between this one and this one. So it reads these points and these points here and builds an average flow direction. So let's build this. So first thing we need is to search the closest the closest points here for all our strokes. So we can use the closest points, of course, for this. That's super handy one. Closest, super handy node. So let's plug in here our tangent spline. And we like to search the closest point on our tangent spline, and the query position is of course the position here of our paint stroke position. So plug this in here, and now here we have the nearest indices, and we have here maximum neighbors and the maximum distance. So distance can be in this case pretty high here, and let's sample around maybe 5 neighbors. Then I think we can also use this as parameters here. And then we have here the nearest indices of our flow spline here, or tangent spline. And then we like to iterate over those indices, so use an iterate collection. So we have here the individual indices, and now we need the tangent information. So let's say get tangent, and then there is here the geometry property get already prepared with tangents. So we have here that already see here the type is already tangent, so we don't need the point position, we need the tangents. And of what? We need the tangents here of our splines. And then we have to say we have an array here with a tuple. So a tuple is can see it as an array with just 2 entries. So we have 2 vectors in this tuple, and those 2 vectors are our tangent points, as I explained. So for this one here, those 2 white points. So these 2 points, these are our tangent points. So inside this array, we have these 2 vectors. So these 2 vectors correspond to these 2 points. Perfect. And with these 2 points, we can build our tangent direction so that we use to align then our splines. So let's get the corresponding tangents to our nearest indices here. So say get element. We like here our tangents, then the element into here. Whoops. And now you can see here the value is a tuple. So this tuple we have to decompose container. And now you can see we have here 2 vectors. So this is for the tangent point 1 and tangent point 2. And now we want to build a direction out of this. So let's subtract one from each other. Subtract. Use vector. So from the first. So here the direction, we can also switch this. So then it goes into the other direction. Whoops. And then of course we like to normalize this direction here, or this tangent vector. Normalize. So it has the length of 1. And now we want to build, as we said, because we have here, we said here the maximum neighbors here are 5. So we want to build an average. We can collect all here our normalized tangent vectors. We can use an average. There are 2 different ways. You can use the aggregate. So that's a very handy one. And here on the aggregate node, we have this stream mode. We can switch it to stream mode. We can say what the data type is vectors. So, and this average, aggregate node collects all our normalized tangent vectors and builds automatically an average. So we can close here our iteration. And now we have here the average direction of all our closest tangents. Okay, to keep some stuff organized here, we can now maybe group this one here, select everything and say Alt-G. Now we have this inside of a group, and we can say here our average tangent, something like this. And let's dive in and this here as an output. And now we have here our average tangent. We can use then to build here our alignment. As I said here, let's go back here. So we have to sample our tangent. So we have here our sample tangent vector, the average tangent vector, and then we like to align the stroke here to the tangent and to the camera. So we have to also bring in our camera. So also say, let's add a new input, add the link, call it camera. Plug in here our camera. And then we need the direction that looks from every point to the camera. So let's show our strokes again. And now we need a direction from each stroke to our camera. So our camera now is here. So we can subtract here the camera position from our stroke position. So here's the camera matrix. So let's decompose the matrix. Now we have here the position of the matrix. And then let's say subtract a vector. So we like to subtract our position from the position of our camera, and also normalize this. Normalize. And now we have here the direction from each point to the camera. Great. And we also have here our average tangent. And with this, we can build here our rotation vector. So we can build here our alignment. And we can do this with a node called alignment. So this one here, and here we can see, first is here the axis. So which axis we like to align. So we like to align here the Z direction. So when we can see our stroke is pointing into the Z direction here. So we like to align the Z direction. In which direction? So we like to align this along our average tangent here. And then the orientation will be, so the orientation is actually the up vector here, so the Y vector. This should always look to the camera. So let's plug here the direction to the camera to the orientation. Then here we just need the rotation here. So we plug in the rotation, bring back here our transition. Then maybe let's have a look, and you can see they look to the camera. Then let's jump into the camera. And I think the alignment of the stroke doesn't work. So let's check what is wrong. So I found the mistake. The problem was because something was selected here. I think it was a polygon or a point was selected, and the problem was here inside the closest point. There's something I always forget here. There is a selection string. So it searched just for the points on this selection string. So we can, let's have a look, instead of default, say here, let's search for all points, just type in all, And here we go. Let's have a look. And now we can see they align along those along our tangents here. So let's add, I think we can also export here on the surface blue noise, of course, our count here. So we can define this here on our capsule. Let's add more splines. There we go. Maybe let's make wireframe mode. Turtle. Now we can see the strokes are aligned along here our sampled tangents. So great. Then I think let's jump to the next step. This will be here sampling the color values. So we could do this the same way as we did in the with the MoGraph setup. So we could make just a vertex map. So maybe let's just make a vertex map and then read the vertex map data. But if you have a mesh that is super low res, I think this is not the best way to do it. So there is a much better way. And the best way is to sample straight the shader. For this, the mesh needs a proper UV. So when you have here turtle, let's check the UV. You can see we have here proper UVs. So the best way is to search for every paint stroke here. We search the closest point on the surface of our turtle. And for this closest point, we use to sample the UV. So we know maybe this stroke here is maybe around here. And with this position, this UV position, we can sample the actual texture. So let me bring up the texture. So you can see here, this is the texture. And when we then maybe use this one, we sample the closest position, then we have the UV position. And the UV position reads then the color value here from this. So maybe the UV position here is the U is from 0 to 1. So this is maybe around here 0.3 and the V is around 0.6. Then we use this UV position to read here the color value. Okay, let's do this. Okay, first thing is we need to know the closest point on the surface for each paint stroke. So there is this node called closest point on surface. Also a very handy node. And we can see here, first we need an object here. So the geometry and the matrix of our turtle. So we can just plug in here the geometry because we already transformed it here. And then we need a position. This is also kind of the query position. So the same as we did here for the closest point. So we use of course, the stroke position. And then we get the closest point on the surface. And not just the closest point on the surface, we also get the index of the polygon where this closest point lives. So maybe let's make some less here again. It is easier to explain. For example, for this paint stroke, so this the center is here, so the closest point is around here. And the closest point on surface gives us also this polygon. So right click, add output, and then we have here the polygon index. And with this information here, we can now sample our UV. So we can do this with an mesh interpolate, is this called? So type it interpolate, you can mesh property interpolate, is it called here? So you can see here, of course, we need the geometry again. So we like to interpolate over the turtle mesh. So plug in this here, and then we have here the polygon index and the position. Let's switch this. And then we have to define what we like to interpolate on our turtle surface, we like to have the UV. Great. So now we have here the UV value, and with this UV value, we can sample the texture. So this node is called sample shader. So let's plug in here the UV coordinate, and now we need the color value. So we need our texture. So this is called image here. Let's use an image. Then let's go and grab here our image. Plug this into here. And then we have here the sampled color. Great. And this color we can use to color here our plane. So because we work here in an instancing workflow. So here our actual plane is an instance. So we have to color here our plane with the object color. So you can type in color, and then there is the color operator. You can pipe in here our plane. You can see they already get black. So we have here the standard color here is black. And now we can use our sampled shader color, plug this into here. And now we can see we have the color here of our turtle. So great. Maybe let's add some more strokes here again. Here we go. Great. So, and then for the last part, as I explained here, we have to build here our lighting. For this, let me explain first how we are gonna do that. So I have here a little setup. So let's think this is here our surface here. This is our light source. And on this surface, there are our point strokes. So now we need to know which surface is pointing to the light and which not. So we look at this surface here. Of course, you have a normal here that points directly to the light. Then this surface is pointing away from the light. This also, and this here something in between. So we need, of course, the normal information of our polygons. So every stroke that we have. So when we think of one of our strokes is here, and we need for this stroke position, we need the normal information of this polygon here. And then also the information from this point to our light source. So we need a direction that looks here to the light source. Maybe let's give this another color. So this is the direction to the light source. And here we have closely the same direction. This direction and this direction. And maybe you already see we have between these two directions, between the normal direction and the direction to the light source, we have different angles. So this has an angle around 60 degrees, this close to 0 degrees, this one close to 180, and this one also close to 180, maybe around 150. And with this value, we can build our lighting, so we can read these values. So we can use a dot product for this, so we don't need to read the angles. So when we plug in two vectors into the dot product, so when the vectors are the same, then we have a dot product of 1. And if they are pointing away, so have an angle of 180, then the dot product is -1. And those values we can use to light our scene or light our surface, or in our case, to light our paint strokes. So let's go back here to our setup here and hide this one. So what we need first, as I explained, we also need the normal. So for every paint stroke, we need the closest polygon normal. So we can do this also with a mesh with here the mesh property interpolate. Let's make some space here. Maybe let's bring this up here and this down here. Okay, and then here we like to interpolate not the UV, we like to interpolate the normals. Actually, I explained something wrong. We don't need the polygon normals. We actually like to interpolate the point normals. So let's make sure our geometry has normals. So let's use, create point normals. So just in case. Great. Now we interpolate over the point normals of our mesh. And then we get here the average normal for our stroke positions. And this normal we can compare now with our light. So we need a light source. So let's add a null. Let's say here also star. So this will be our light source. And we also have to bring the light into our setup. So again, let's add a link. Call this light source. Maybe let's call this light. Then here, bring here our light source up to here. Now we have here the position here of our light source here. Here we go. And then we also need the transition. So same as we did for the camera. Let's use a subtract. Subtract. Here, subtract from our position. Subtract here the position of the light source. And then let's normalize this. Normalize. Great. Also normalize here our interpolated normal here. And then let's build the dot product. And because the dot product goes from -1 to 1, we have like to map this. So mapper, let's use a range mapper. Whoops. So the input is from -1 to 1 and the output will be from 0 to 1. So great. And this we can use to add this here to our color. So let's zoom in so we can see what will happen. Maybe let's hide the turtle. And this is the same as we do it inside of a shader. So we can use a layer for this. So let's add 3 layers. Then the initial layer here, the initial colors here, actually the sampled color here. And then we could use just 0 to 1 to into the color, but of course we like to define here the color values of our darker areas and our lighter areas. So we could use a gradient. This is the easiest way. Oops, not this one. Basic gradient. Plug in here to the position. Bring this up and say this is here our light values. Maybe here from a yellow, and the brightest one is something green. So let's try something. Then we like to add this to the layer 1. And of course, because this here is our light values, we like to add this. Add or screen. Doesn't really matter. And then here we switch it around. Let's make this white. This will be our shadow colors. So maybe from a dark blue here up to a kind of pinkish purplish color, something like this. And this we add to the layer 2. And then let's say multiply, of course, and then plug this new value here into our color. Let's check. So I think something went wrong. So let me check. I found the problem. So it's not similar to the shader, like when we build it in the shader, the layer here. So it goes not from top to bottom, it goes from bottom to top. So we have to switch it. First here at the bottom, the sample shader, and then the shadows, and then the light, and then say that our sample colors normal, the shadows are multiplied, and the colors, we like to add the colors. And here we go, and it's the wrong way around, so we can flip it here inside our range mapper. So, and here we go. Now we have a light source, and with this light source here we can color here our paint strokes. So, and now let's add here our texture to the paint strokes. Let's deactivate the texture and Q, so we can see it inside the viewport. And let's open here our Redshift render view. Let's press play. I think something is wrong inside our shader here. Let's check. Yes, we have here still the MoGraph color, because this is not the MoGraph color, this is actually the object color. So the object color is normally here, this it's the display color, not the object color, sorry. So instead of the MoGraph color, we like to have the, go to object, say display color. Oops, or is it the object color? Yeah, it's the object color. Great, and now of course we can play around here, maybe the minimum scale just 0.7. And then cool thing now is we can paint here. We have here our strokes. Let's show the turtle, and we can add additional strokes. Maybe let's go to the bottom here and say around here, the turtle, to our spline, and then we add additional splines. Yeah, and you can see it aligns here to our newly created splines here. Yeah, I think we also can delete all splines and paint some new one. So that's it for the setup. And now let's jump to the last part where I show you the advanced capsule. So this one here is the advanced capsule, and you can download this also on Gumroad. And so let me show how this works. So here we have the first input stuff here. So in this example here, so when nothing is placed here, you have this ball here. So in this case, we like to use here our raccoon. So this is from the content browser. So here's our raccoon, and this is actually also animated. So, and here are the splines. I already painted some splines. So let's activate our paint stroke capsule and bring in here our raccoon. Great. And then say we can define here the selection string. If you say, okay, we just want to put it here onto a one part. So here the face, or maybe we have a better one here. That's the tail. Yeah. So if you just want them, the paint strokes on the tail. So if you can add multiple capsules to a single surface. So let's go back to all. Then let's add our tangent spline here. Great. Oops. Again. Oops. And then, of course, the texture file. So let me take the raccoon here. Great. And then we have here a different sampling type. So the tangent one's the one that we built, so it reads the tangents. But if you have splines that have no tangents, you can also switch to points mode. So then it searches for the closest points, and out of these points, it builds an average direction, so where the strokes will be aligned. And then, of course, how much neighbors you like to search, and the search distance. And when you press play, you can see they are on the surface, but because the surface is changing, also the strokes are changing. So you can attach the strokes to the surface. So let's say snap the stroke and also snap the spline. So let's press play, and now you can see it is stitched to the surface. For this one, you need to resample the spline, and this also just works here in point mode. So when you go to tangent mode, you can't snap the spline, just can snap the strokes onto the surface. So now the strokes will stay, but not the spline. So go to the points mode for this, and now everything snaps to the animated surface. Then, of course, you have the stroke settings here. You can say how many strokes. And then you have here a distribution seed where you can change the distribution. Then the distribution sampling. So this is a setting of the surface blue noise here. If you like to have better distribution of the paint strokes. And then next is, of course, a random color seed. So you have here also, you can also add some random colors. You can see. And then, of course, the width and the height of the stroke. Then the segments of the stroke. And then the stroke offset to the surface. So you can push it outwards or inwards. And then there is also an additional stroke bend, so you can start to bend the strokes. It's also sometimes a cool effect, so maybe let's render it. Let's see, let's hide the raccoon here. Here we go. You get those bendy strokes. Yeah, something like this. Then, of course, the minimum and maximum scale, and then also the scale seed. And then there's also something called scaled by vertex. So when you want on some places smaller strokes and some places bigger strokes, you can do this with vertex map. So you can activate this. So here, for example, let me show you. I have the raccoon here. And on the raccoon, I calculated the curvature here. So I have this curvature map. So and now, everywhere where it is red, I have small strokes. And at the other parts, here where it is yellow, I have bigger strokes. I have to add this to the vertex map. And now, let's press play again. You can see here on top, let's hide the raccoon, we have smaller strokes also here on the nose, and here we have bigger strokes. Then go to the light and camera settings. Then, of course, you can align it to the camera. There are some cases you can say, okay, don't align it to the camera. Could also be a solution if you want an effect like this. But in most cases, align to the camera makes most sense. And then, of course, the camera object and the light object, and then a global brightness value, so where you can dim the texture here or brighten the texture, and then of course the color gradient and the shadow gradient. Yeah. So that's it for this tutorial. Of course, it was a long one, but I hope you liked it and learned something. You can download all the files on Gumroad. You find this in the description of this video. So that's it. Then have a nice one. Bye bye.